In this video, our learning target is to learn how to draw the Lewis dot structure for compounds. So first we need to know what exactly Lewis dot structures do for us. So in a previous video we talked about how to draw Lewis dot structures for elements. You'll want to make sure you know how to do that first before watching this video. So in that previous video you learned that electrons want to be alone before they're paired up. So they want to be alone on each side before you pair them together. So in this particular example with sulfur, we can see that there are two unpaired electrons. We have paired electrons here, but there are two that are unpaired. So these unpaired electrons are the ones that will be able to form bonds. So since sulfur has two unpaired electrons, it will be able to create or make two bonds. So here's a helpful saying, honk. What this means is hydrogen has one valence electron, one unpaired electron. So everything in the hydrogen column will be able to make one bond. Oxygen has 6 valence electrons, so everything in the oxygen column will be able to form two bonds. We can see that oxygen has 2 unpaired electrons. Nitrogen, everything in the nitrogen column will make 3 bonds because nitrogen has 5 valence electrons. So we can see that there are 3 unpaired valence electrons. And then carbon, everything in the carbon column will make 4 bonds because carbon has 4 unpaired valence electrons. So when we're drawing Lewis dot structures for compounds, we need to follow 5 different rules. So our first rule is that only unpaired electrons can bond. So any electrons that are paired, so let me show you an example of paired electrons, those cannot bond. So in this structure, oxygen has 2 sets of paired electrons. Those electrons do not form bonds. Second rule, 2 electrons make a bond. So let's say we want to bond hydrogen and oxygen. Hydrogen has 1, and so we can form a bond between this one valence electron in hydrogen and the other unpaired valence electron in oxygen. Third rule, hydrogens like to be on the outsides of molecules, so they never want to be in the center. Fourth rule, there should always be 8 valence electrons around every atom, with the exception of 3 elements. Hydrogen wants 2 around it, beryllium wants 4, and then boron, which wants 6. And then fifth rule, make sure that you still have lone pair electrons drawn on atoms that need them. And we'll go through what exactly this means. So let's try a couple examples. So in this first picture we have H2S. The element that is by itself goes in the center. So we will put sulfur in the center and we'll have 2 hydrogen atoms on either side. Sulfur has 6 valence electrons. 1, 2, 3, 4, 5, 6. We can see that there are 2 unpaired valence electrons. And then each hydrogen has 1. So a bond forms between 2 electrons. That was rule number 2 on the previous slide. So we're going to create a bond there and a bond there. I'm just going to clean up this picture. So I'm going to have 2 sets of paired electrons on sulfur, and then a bond between the sulfur and each hydrogen atom. So rule number 5 here was to make sure that the lone pair electrons are still drawn on atoms that need them. So what that means is that sulfur still has these paired valence electrons on it. We didn't drop those. The next example, we have BeF2. So again, the element that's by itself will go in the center. Beryllium has 2 valence electrons. and then fluorine has 7. So we're going to be able to form a bond here and a bond here. So I'm going to draw a line to represent a bond. This line, this one line, represents 2 electrons being shared. We're going to look at 2 more complicated examples with double and triple bonds. So a double bond is where we have 4 valence electrons being shared between 2 atoms, and then a triple bond, we will have 6 valence electrons being shared between atoms. So carbon dioxide, this is CO2. Carbon is in the center. Carbon has 4 valence electrons, and then oxygen has 6. So there's a couple things I want you to see here. First of all, carbon has 4 unpaired valence electrons. That means it wants to form 4 bonds. Oxygen, each oxygen atom here has 2 unpaired valence electrons. Therefore, each oxygen wants to form 2 bonds. So we're going to draw a bond forming there, and then another bond will form here. So we can see there's 4 electrons being shared between these 2 atoms. This tells us that a double bond has formed. So we're going to clean up our picture. And this is the way that we're going to draw double bonds. We're going to draw 2 lines, like an equal sign. So there's our final picture. Here's our next example, HCN. So we're going to put carbon in the middle, and then we'll have an H and an N bonded to it. Hydrogen has 1, carbon has 4 valence electrons, and then nitrogen has 5. So 3 things I want you to see. Hydrogen has 1 unpaired valence electron. That means it wants to bond 1 time. Carbon has 4. That means it wants to bond 4 times. And then nitrogen has 3 unpaired valence electrons. That means it wants to bond 3 times. So we're going to draw a bond, 1 single bond between carbon and hydrogen. And then we're going to be drawing a triple bond showing that 6 electrons are being shared between carbon and nitrogen. So we're going to make that look nice. Hydrogen will have a single bond to carbon, and then we'll have a triple bond represented by these 3 lines here to nitrogen. And nitrogen still has that lone pair of electrons. So pause the video, try these 3 examples here. On the next slide, I'll show you the answers, but I'd like you to pause the video first, see if you have learned the concept, and then check your answers. So here are the answers for the 3 examples that I wanted you to try.